Hello again, class. We're going to be going over trophic levels, ecosystems, and a bit of Lewis structures as was requested in class. So let's get started. So as you can see, I've got a little diagram about trophic levels already set up. And I'd like for you to notice that in trophic levels, always at the bottom, you will have plants at the base. Plants are always going to be the ones that produce energy from the sun and nutrients. They're at the bottom. They're the ones producing or creating all the energy from the sun and from the inorganic material and bringing that energy into the trophic level. Notice the arrows over here pointing towards what is doing the consuming. So plants are being consumed by herbivores. Herbivores eat the plants. You've got another arrow pointing towards the first level carnivores, which are eating the herbivores, and so on. Another arrow pointing towards the second level carnivores, which eat the first level carnivores. What happens is the level or the order highest, in this case if we take for example second level, you're always going to be eating the level below it. So first level eats herbivores, second level eats first level, and so on. The next slide over here talks about biomass, if you will. So biomass over here refers to mass of living organisms. So bio, coming from the Greek word bio, meaning life, and mass. So it's the mass of the living organisms in your ecosystem. And what you'll notice is at the bottom you've got your autotrophs. Again, autotrophs means plants. They are autotrophic because they are self-producing in terms of their food. They get their energy from the sun and it feeds the plants. They produce their own energy. Notice that the amount of autotrophs is a lot larger compared to the highest order of animals. Every time you take a step upwards, you are decreasing in biomass. So what this means is that overall, plants will have the most biomass. And the higher level consumers, the least amount of biomass. Don't forget that we have a term known as primary productivity. Primary productivity, which refers to the biomass but of the primary producers. So primary productivity refers to the autotrophs and their biomass. Here we have a little pyramid showing you, again, the same thing that was explained on the previous slide, that your producers at the bottom are always going to be the widest in terms of biomass. You will always have more producers than everything else considering they're at the bottom. And every step upwards, you're decreasing in biomass. And that has to do with the fact that as you go above, you're losing energy along the way. Energy is lost in terms of, let's say, the primary consumers generating heat from when they eat the plants and other forms of ways of losing that energy. So again, you have a similar diagram showing you the majority of your plants at the bottom. You have more plants than you will have other levels. So here we have more plants than we have mice. We're going to have more mice than we have snakes. And we're going to have more snakes than we have hawks. And this has to do with the fact that they are going upwards in order. So this was mentioned previously. I don't think I need to stress this anymore, but what I would like to cover is the terminology again. Plants are producers, but what you do need to know them as specifically is autotrophs. And this is the primary producers. This is pretty much the only thing that undergoes, or that has that name. All consumers, be it mice, snakes, and hawks, go by heterotrophs because they need to consume others for their energy. Notice, however, that we have nothing mentioning decomposers. Decomposers are always present in your ecosystems, but so far they have not been displayed graphically. Decomposers, the term you will need to know is detrivore. Remember, detri comes from the word detritus and vor meaning eating, just as in carnivore means eating meat, herbivore means eating herbs or plants, detrivore means eating dead material. So decomposers are present. Decomposers can be mushrooms, they can be worms, they can be bacteria in the ground. So these are the main three things you'll need to remember as being decomposers. And what they do is they decompose every once living organism back into inorganic matter. So plants, over here, plants take the inorganic matter from the ecosystem and make it organic. And in doing that, they make plants. They also help make other animals when those animals eat those plants. But once everything dies, the decomposers take that organic matter and bring it back into the environment for the plants to continue that cycle. So at this point, I feel as though most of you should be okay with ecosystems, and I was also asked to cover Lewis notation. So here we have a Lewis notation review. For Lewis notation, what you will need to know is two simple things: the chemical symbol as well as its valence electrons. So we have an example set up, bromine. If we are going to be using bromine, we will need a periodic table. Once you've located bromine on the periodic table, you need its valence electrons. So valence electrons, as we've mentioned before, is at the top. Remember, you do not consider the 1, you are considering it as a 7. So it has 7 valence electrons. Knowing that it has 7 valence electrons, all you will need to do for any Lewis notation is write down its chemical symbol. In this case for bromine it is Br. And in a clockwise order, as though there were a box around it, you must place 1 electron at a time. I'm going to remove the box for this case, but you have 1 at the top, 1 on the right, 1 on the bottom, 1 on the left. Notice that I will make a full rotation before I start pairing up my electrons. Only once that I have 1 on each side can I start pairing them up. So far I have 2, 4, 6. I need 1 more to have a total of 7 valence electrons. And this over here is how I will be doing, or you shall be doing, Lewis notation for any chemical on the periodic table. So now let's try a practice problem. Let's take calcium right over here, calcium, and let's have you try this one on your own. So pause the video now, try it out, and check to see if you get it right. So I'll give you a moment to pause and we will go over the answer shortly. So calcium, its chemical symbol is Ca. We need to know its valence electrons. It is 2. So simply, going in a clockwise order, we will put 1 and 2 valence electrons like this. Note that calcium will not have them paired up like this. This is wrong. As I said, you go in a clockwise order. You do not pair up until you have made a full revolution around calcium. So that'll be it for Lewis notation, and just as a bonus I want to remind you that you will need to remember pH as well as how to identify salts, acids, and bases. Salts are a combination of metals and non-metals. Acids generally start with an H, for example HCl, and bases will always or generally end in OHs like NaOH. There are exceptions. For acid, the exception is going to be anything that ends in COOH. Yes, it ends in an OH, but because it has a COOH, this is the exception. That is an acid. For base, NH3 is one of them. And an example for a salt, although this is not an exception, we've got a metal, let's say sodium and chlorine. Sodium chloride is a salt. In terms of electrolytes, all of them, salts, acids, and bases, are electrolytes, but they are only electrolytes when added to water. Remember, in class, I tested with that machine that had a light bulb on it. It would light up when there was an electrolyte. It would not light up in just a powder. But if it was in a solution, it would light up. So salts, acids, and bases are electrolytes only in water, not as solids. At this point, we have finished the review. I want to wish you all the best of luck in your studying and on the exam. And if you have any questions, please send me the question through Edmodo. If you would like to have me do one more video lesson, please request the topic and I will see what I can do. Hopefully I will have enough time to send it to you and have it done before your exam. So good luck, study hard, and hopefully you get the best grade possible.